This week at NASA.
3, 2, 1.
Turbo pumps, that's flight speed.
Liftoff. Liftoff of the Soyuz TMA-05M.
The Russian Soyuz spacecraft carrying Expedition 3233 Soyuz commander Yuri Malenchenko, NASA flight engineer Sonny Williams, and flight engineer Aki Hoshide of the Japan Aerospace Exploration Agency heads to the International Space Station following its launch from the Baikonur Cosmodrome in Kazakhstan.
40 seconds into the flight.
Malenchenko, Williams, and Hoshide are joining up with Expedition 32 Commander Gennady Padalka, NASA astronaut Joe Acaba, and cosmonaut Sergei Revin, who have been on the orbiting outpost since May. When the Curiosity rover sets off from its landing site near Gale Crater to explore the Martian surface, the Mobile Science Laboratory might encounter some sand dunes. Project engineers at the Jet Propulsion Laboratory have prepared for that possibility by putting a test rover through the paces here on Earth.
Through careful targeting, we've been able to shrink the landing ellipse for Curiosity, and we've been able to move it closer to where we want to actually land. In case we land in dunes that are like this on Mars, near the landing site, we want to be sure that the real rover is able to navigate around successfully in those dunes and get from the point where we landed to the point where we really want to be. So we've come out here today with the Curiosity Scarecrow rover, which is the same weight on Earth as the real rover is on Mars, to practice driving it around in the nearest thing to those dunes on Mars that we're going to find here on Earth. This is similar material and similar slopes to the dunes that we're going to find in Mars. So being able to test this rover in these dunes gives us a good idea about what the performance of the real rover is going to be in the dunes that we might land in on Mars.
Still making progress.
The performance on this rover is actually fairly similar to Spirit and Opportunity. A little bit better. We can climb in soft sand up to about 15 degrees or so, which is a little better than Spirit and Opportunity will do. We are in fact right now maneuvering it from an area of about 15 degrees of tilt to an area of about 25 degrees of tilt to try to explore where that break is in its performance. Our top speed is very slow, but our acceleration of that top speed is pretty much instantaneous. So we go from a dead stop to right about as fast as we're going to go pretty quickly. And it's really fun to, like, every once in a while, kind of leave the office environment behind and come out to an environment like this and see what the real rovers are going to be doing on Mars. It kind of connects you to it and reminds you that, that the computer models that we play in are a far cry from reality. This is that reality.
NASA's Cassini spacecraft has spotted a concentration of high-altitude haze and a vortex swirling in the atmosphere high above the south pole of the Saturn moon Titan, hinting that a change of seasons may be coming on Saturn's largest moon. Cassini researchers say the structure inside the vortex is reminiscent of the open cellular convection often seen over Earth's oceans, but they are at a very high altitude on Titan, which may be a response of Titan's stratosphere to seasonal cooling as southern winter approaches. The vortex was imaged during a June 27th flyby. Deputy Administrator Lori Garver joined Glenn Research Center Director Ray Lugo, congressional leaders, and White House representatives at Ohio's Cuyahoga Community College near Cleveland for a workshop on building the National Network for Manufacturing Innovation. Garver emphasized how important the nation's manufacturing capabilities are for NASA, space exploration, and keeping America's new technology economy competitive.
Advanced manufacturing capabilities are essential to turning research discoveries, inventions, and new ideas into better or novel products. Our nation's ability to innovate is unmatched.
Garver also pointed out the important role played by Glenn in creating technologies for NASA that also benefit American manufacturers. NASA is supporting President Obama's call for new institutes for advanced manufacturing and will participate in a pilot institute later this year.
When rovers land on Mars, they travel all the way to the red planet protected by a rigid aeroshell, or heat shield. The size of that structure limits just how much scientists and engineers can fit inside.
If you look at all the origami that's involved in packing a rover, like we're sending to Mars right now, into that confined space, and then having it deploy in the right sequence during that timeline when you've only got a certain amount of time to do it, it's very complicated.
So Neil Cheatwood and his colleagues at NASA's Langley Research Center in Hampton, Virginia, have come up with a different idea: an inflatable heat shield. The first flight demonstration of the concept is the Inflatable Reentry Vehicle Experiment, or IRVE. The launch of the 10-foot diameter mushroom-shaped IRVE-3 which is packed uninflated into a 22-inch diameter rocket, is currently scheduled for mid to late July.
We will launch ERV-3 on a sounding rocket out of Wallops Island. It will go up into space, inflate to reentry shape, and perform its reentry experiment, and it will radio the data back home. When the experiment is over, ERV-3 will land out in the Atlantic.
ERV-3 has been tested and retested on the ground to make sure it can withstand the heat and force of atmospheric reentry. The first line of defense against those conditions, the thermal blanket, is made up of layers of commercially available materials.
This combination includes Nextel, which is an aircraft engine insulator. We use Pyrogel, which is a pipe insulation material. And then we use Kapton-coated Kevlar. Kevlar is the same stuff that police use in bulletproof vests.
ERV has already had one successful test. Assuming ERV-3 does as well, engineers hope to expand the concept, literally, and test a larger inflatable in the future.
On July 12th, the Smithsonian and the Embassy of France marked the 50th anniversary of the first transatlantic images transmitted by Telstar 1, the world's first commercial telecommunications satellite, with a live telecast between the National Air and Space Museum in Washington and the Cité des Télécoms in Plamur-Boudou.
What a tremendous engineering achievement it was, and how it really began a new era that we now just assume is going to continue into the future, really, but it had to begin with a very small step.
Telstar 1 was launched by NASA. The first Telstar transmission 50 years ago marked the advent of the exchange of global information and the commercial use of space.
Who can tell me where the International Space Station is? Yes.
NASA Deputy Administrator Lori Garver spoke to a group of young female students who were visiting NASA headquarters as part of the Summer Institute in Science, Technology, and Research, or SISTER program.
I love making a difference. I feel like we were put here to leave the world better than we found it. And I think it's pretty rare that you get to be in a job where you feel you do that every day.
Sponsored by Goddard Space Flight Center, the 5-day program is designed to introduce middle school girls to industry professionals like Garver in hopes of increasing their awareness of the opportunities available in non-traditional career fields such as science, math, and engineering. July 15th marks the 37th anniversary of the first international partnership in space, the Apollo-Soyuz test project. On that date in 1975, an Apollo spacecraft carrying astronauts Tom Stafford, Vance Brand, and Deke Slayton launched from the Kennedy Space Center and 2 days later docked with a Soviet Soyuz spacecraft and its crew of 2, Alexei Leonov and Valery Kubasov. Designed to test the compatibility of rendezvous and docking systems and the possibility of an international space rescue, the 9-day Apollo-Soyuz mission brought together the 2 former Cold War spaceflight rivals to work and perform as a team. The successful Apollo-Soyuz test project paved the way for future international partnerships. And 1 year ago, on July 15, 2011 Pacific Time, after nearly 4 years of travel through the solar system, NASA's Dawn spacecraft was pulled into the orbit of Vesta by the giant asteroid's gravity. Dawn became the first spacecraft to orbit a main belt asteroid located in the region between Mars and Jupiter, about 117 million miles from Earth. Images and data collected by the spacecraft of Vesta and the dwarf planet Ceres, Dawn's next stop, will help scientists characterize the early solar system and the processes that dominate its formation. Dawn is expected to leave Vesta's orbit late next month and arrive at Ceres in February 2015. And that's This Week at NASA. For more on these and other stories, or to follow us on Facebook, Twitter, and other social media, log on to www.nasa.gov.